So welcome. So now discuss types of optical fiber in the part of based on the variation in the refractive index of the core and the gladding. The fibers are classified into two types: wise step index fiber, graded index fiber. So first we talk about step index fiber. So here the refractive indices of air, gladding and core varies by step, and hence it is called as the step index fiber. So in the step index fiber we have both single mode and multi-mode fibers. And both of the fibers are variation in refractive indices will be in the step by step. So since a single mode fibers has a less dispersion than the multi mode, the single mode step index fiber also has a low intermodal modal dispersion compared to the multi mode step index fiber. And graded index fiber, so here the refractive index of the core varies radially from the axis of the fiber. So the refractive index of the core is a maximum along the fiber axis and gradually decreases. So thus it is called as graded index fiber. So here the refractive index becomes a minimum at the core gladding interface. So in general, the graded index fibers will be of a multimode system. The multimode graded index fiber has a very less intermodal dispersions compared to the multimode step index fiber. A typically multimode graded index fiber as shown in figure, see the diagram. And therefore the propagation of light in green fiber, light Ne, Nb, Nc, Nd, etc. The refractive indices of different layers in the graded index fiber with Na greater than Nb, greater than Nc, greater than Nd, etc. The propagation of light through the graded index. So hence since Na greater than Np, so the ray gets refracted. Similarly, since Nb greater than Nc, the ray gets refracted in a similar manner due to the decrease in refractive index. The ray gets gradually covered towards the upward direction and at one place. So where it satisfies the conditions for total internal reflection pi greater than pi c, it is totally internally reflected. So the reflected ray travels back towards the core axis but not cross it. So and without crossing the fiber, it is refracted towards downwards direction and again gets totally internally reflected and pass towards upward direction. In this manner, the ray propagate inside the fiber and in helical or spherical manner. And a difference between step index fiber and a graded index fiber. So first we know step index fiber and then graded index fiber. So the difference is the refractive index is obtained in a single step and hence called a step index fiber. Due to the non-uniform refractive index, the difference in refraction index is obtained gradually from the from center towards the interface and hence called a graded index fiber. So here step index fiber, the light ray propagation is in the form of meridional rays and it passes through the fiber axis. In a graded index, the light propagation is in the form of skew rays and it will not cross the fiber axis. So the path of the light propagation in this zigzag manner in the green fiber is that the path of light propagation is a helical or that is a spiral manner. Step index fiber has a lower bandwidth and graded fiber has a higher bandwidth, that means multimode. And distortion is a more in a multimode step index fiber, that means when a ray travels through the longer distance there will be some difference in the reflected angles. Hence, high angles rays arrive later than the lower angle rays. So, therefore, the signal pulses are broadened, thereby they result in the destroyed output. And gradient index distortion is less or no distortion due to the self-focusing effect. So that means the light waves travel with different speeds in different paths because of the variation in their refractive index. At the outer edge, it travels faster than the near the center, but almost all the rays reach the exit end, and the same time is no dispersion in the pulse, and hence the output is not a destroyed output. Thank you. We discuss in the next session.